member Suresh, myself, and Umar. So, as you have already seen object detection module by Devin, which was already a great work done from the team B. So, I will actually, our team, team D is was getting a lot of errors. So I'll share what are the mistakes or what are the possible errors that you can get in the meantime. So let me first give a overview. What we did is we were performing object detection module and detecting objects in Indian roads, particularly because we have to focus on that. Our video dataset provided to us that is around 7 minute long videos, and we collected around 1300 plus images. I guess 1328 or 29. Using frame extraction. And then we annotated that images. So the steps that we followed was like this. We collected dataset, perform annotation using level mean, then we converted it into CSV from XML file, then we splitted data, then again we need a TensorFlow record file in order to perform training. Then we took one of the famous model, that is COCO SSD mobile net, and then we trained the model in the cloud. So before that, so this is how we converted the images into their respective XML. You can see here. Then you need test and train data that we splitted. So this is the required dependency or a pipeline that you have to follow through in order to reach to the training part. So the first thing that we did was install Anaconda, then also libraries. So the first problem that we encountered was the libraries version that we need to update. So you have to be very careful because any of the there could be cross dependency between the libraries. So we need to properly update our libraries. Then also we require a GPU wheel package, which is by Tensorflow, and then obviously object detection API, which you can get through GitHub, and record generator file, and finally a GPU. So this is what you will get as a TensorFlow record. You can see here. If you guys remember, during annotation we had given our item name labeled as car, truck, bus. So those are provided with ID like this 1, 2, 3, 4, 5. You can see here, and this is I'll say this while going for training, there are a lot of problems or a lot of obstacles that you can face. So this is one of them. This could be because of if your system is having lesser memory as expected, so this could happen. So you have to keep in mind this thing also. So a lot of mistakes made, and I would say a lot of lessons learned, because mistakes are what makes you what teaches you properly. So the first mistake that we did was while creating instance only. So it would be better if there is already an image. It would be better to create it with that. Then pipeline should be the pipeline that I showed previously. This pipeline should be done step by step without installing one dependency. You cannot go for another dependency. So that will also lead you nowhere. And also path and dependency are exactly this places where we all are getting a lot of errors. The relative path, absolute path. So, and the one thing that I discovered today was always we need to set path on super user mode, because I was not in super user mode, so I used to set path. Then again, when I used to come back, the path that I had set was not stored on system. So this was creating a lot of problems. So this thing has to be kept in mind. So these are the mistakes. I'll call them. These are the lessons that I've learned today. And I would like to talk about training approach that we are going to do. I guess by tomorrow we'll finish that. So the approach will be use transfer learning. So for those guys who are unable to grasp, this is actually what we'll be doing. So you can see here there is a source data ImageNet. It is a famous data set by Stanford scientist Fafeli. She had started collected, I guess, by 2004 or 2005 this image data set, and it's a huge data set now. It's an open source. You can use it to train your model. So this is a source model. So it's already trained and it has pre-trained weights. That means the knowledge, the model has some knowledge. Knowledge in the sense the model is capable of performing something. So the knowledge of that model can be transferred to our next model along with our data set here, so that we can create some target level. The advantage of using transfer learning is that if we are training our model from scratch like this, like this, you cannot achieve good accuracy. But if we'll use pre-trained model like ImageNet and other pre-trained models, they will have some checkpoints already created, some weights initialized. So using that weights, we can combine with our weights and we can create a good model. So it prevents the random initialization of weights. We can avoid that and we can build a better model. So this is a basic idea about transfer learning. So what it covers is transfer learning. What we did on our project is use an SSD, MobileNet. This was one COCO dataset, and it is also known as inductive transfer. You can see that, and the main part is as I told, pretend words. So on our context, what would I say? Why we use this is, suppose if this dataset was trained to recognize cars, we could apply this dataset and we could apply the knowledge gained by this model while recognizing cars. We can apply that to recognize the trucks or any other objects in our image. So this is the actual advantage of using transfer learning. So you can make that out by name only. So you are basically transferring the model and transferring the weight or transferring the knowledge gained by the model. So yeah, I was also looking into data synthesis part, because as Devin had suggested that our model, it doesn't have that much as accuracy as expected. So for that, what we can do? So one solution that I was looking into was data synthesis, and there are a lot of ways to do that, but one particular way would be augmentation. Augmentation is nothing but basically changing a property of existing data to increase, like the image data, to increase the amount of data. So if I have an image, I'll show that also. I have a demo for that. I'll show that. So if I have an image A, if I change the property of image in such a way that the objects in the images are not affected, but the image will be counted as a different image. So because of this, if you have lesser data, our model can underfit, or if we have very few images, the model cannot make out of what the object actually is. So for that purpose, we can go for data augmentation. I'll show you how it has done here. Here we can see that. Suppose this is a traffic sign recognition project done on this is a Jupyter notebook. So you can see here a lot of data. Suppose this image is of class 0. You can see it's a 20. It's a traffic signal. It says this image has object or number 20 that we have to recognize. So if you can see class 1 is 30, class 2 is 50. There are a lot of images. But if we say we can pre-process this image in such a way that the first thing is you can convert it into grayscale. So these two are different images because of the number of color channel. It has only 2 because of gray images, and it is in RGB, right? Because it has got all the color images, red, green, and blue. So here you can see I'm sorry, here you can see on data augmentation part, what we can do is, suppose this is an original image. You can see, if you can you figure out differences between these two images? You can see this object is same to this object, but the difference is actually this object is flipped. You can see this object is flipped vertically. So you can see this black part of this image has come to the upper part. So that means this image is flipped horizontally, and you can see here this image is flipped vertically. This part has come to this part, right? This black and this white speckles has come to this part. So you can see the same image. The object is not changed because this is a symmetric image. So if you have such symmetric images, we can go for data augmentation. Now with one images, you can see 1, 2, and here also 2, 3, 4. With one original image, how many synthesized images did we create? Just 1, 2, and 3. This is also synthesized image, right? So you can create a lot of like that. Not only this, there are other way of doing this, but basically data augment you can see here also the because if original image class 37, you can see this class image class 37, it has directions to go to forward and to left, right? So if we don't have any data to, for depicting any signal to go to front and right, we can just flip it like this 90 degree or 180 degree, right? So this is a synthesized image, but if we have any data set like that which is symmetrical on any of the axis, this would be your y axis, this would be your x axis, right? So this particular image is symmetrical on you can see y axis, right? If we change y axis or x axis, this particular direction will alter from left to right. So you can see here we just synthesized an image. This image was not there, but we just created this image from this particular image. So this is the basic logic behind data synthesis, I would say. So we can do that to increase our number of images or number of data set, so that we won't underfit our model, so that we won't lack data in our model. And yes, that's pretty much. I'll thank you. I'll be done. We'll be done by tomorrow. Our team will be done by tomorrow. We haven't done. We are stuck in training part, so that will be done very soon. So yes, thank you. You can take over.
Roshan, any submission, any video, anything?
No, sir, I haven't. I mean, we haven't completed training. That's why.
Sure. Umar and yeah, Umar. Okay.
Yeah, he's there.
Okay. Umar, like, do you Umar is actually facing some issue in while doing some work, and he needs some proper guidance. I think someone has to guide him in terms of making possible to training for himself. So yeah, Devin, you can connect to Devin itself. I think Devin will be the right person to get help with too. Okay, and one more thing, in case of more than one level, whenever we talked about, so we can apply rotations and other things for one level image, but when you apply rotations for more than one level image, it's slightly tougher, and it's sometimes doesn't work, because think of if you have 6 or 7 or 10, and if you are rotating, so in that case it will get overlapped.
Yes.
So these things we need to keep in mind that. Yeah, so
that was I mean that was just an plain idea about this is how we can do or rotating angle also works in that particular street sign, but ours is totally different case. Right. So that was just a plain idea. This is how we can do data augmentation.
Sure.